I'm Doug, and this is my video about the anatomy of the brain as it relates to the visual system and how vision flows from the eye to the brain, how it gets processed, and what could go wrong if parts of this system have been damaged. So let's start with the brain itself. Behold, the human brain. This is a view from the right side. So let me get a better grip on this. Here we go. Okay, so the eye would be around here. So what is relevant for our purposes today are where does the vision go? So let's start here at the back. This is the occipital lobe. Okay, then over here, this is the temporal lobe. And then this up here, this is the parietal lobe, and this up here in the front, this is the frontal lobe. Okay, so this is the brain from the back. So notice the brain comes in two hemispheres. The occipital lobe is back here. This is the brain from the front, so frontal lobe, and this is the brain from the top. Frontal lobe, parietal lobe, occipital lobe. And once again, the temporal lobe, parietal lobe, temporal lobe. So, how do we see? So vision starts with the eye. The eye gathers light and information. This light information is then transformed into electrochemical impulses that are carried by the optic nerves. These optic nerves then travel through the eye to this region here, the thalamus. Okay, inside the thalamus is a region known as the lenticular ganglionic nuclei, the LGN. Basically, at this point, the visual information is combined. So the left eye and the right eye and are separate up until it reaches this point, as well as the M cells and the P cells. So your peripheral vision, your central vision, it all starts to come together here. Then the optic radiations will travel from the thalamus to the back of the brain, to the occipital lobe. All right? And it starts at region V1, which is down here. This is the primary visual cortex. So then, what happens? So this right here, the occipital lobe, the vision centers in the occipital lobe. This is the brain's print shop. Okay, this takes the sum total of all this information and it provides us with color and visual acuity. And basically the sum total of the image is combined right here. Then the information splits up into the dorsal stream and the ventral stream. So the dorsal stream of vision travels through the occipital lobe to the parietal lobe. And the ventral stream travels from the occipital lobe to this blue part, the temporal lobe. All right, so why is this important? So the dorsal stream, this is how our visual information gets translated. It's also the dorsal stream is referred to sometimes as the where stream. So it processes information like what direction is something moving? Is it moving towards me? Is it moving away from me? Gives us an estimate of speed. Is this thing moving fast, like a child's balloon blowing on the wind, or is it heading is it heading slow, like a child's balloon on the wind? Is it heading fast, like a fastball? You know, when you're at the batting cage. It also gives you depth. It gives you an idea of how far something is from you. Basically, the dorsal stream is also known as the unconscious stream. So this is where a lot of our visual/physical information is integrated so that our body can take a step down a curb, so that our hand could find our fork on the table, and things of this nature, versus the temporal stream, which is referred to as the what stream, or the sometimes known as the conscious stream of visual information. So within the temporal lobe, this blue section right here, this is what gives us allows us to name the items that we're looking at. So, oh, that's a fork, or oh, that face, that's mom. So it allows us to basically give definition to our world. It also provides us with the analysis of motion. This is a really critical stage of visual information. Basically, it allows us to have this fluidity of motion, this perception that things are moving, as opposed to like a comic strip, where it's a click, click, click. If anyone's ever read a comic book or a comic strip, then you get what I mean. So, and then the information from here goes to the frontal lobe, where our critical executive functions start to kick in. So it gives us our decision. Do I want to use the fork for my salad? Do I want to use the spoon for my soup? Things of this nature. So that's basically the visual process in the brain. So what happens when things go wrong? So when you have a cerebral visual impairment, it can go down the dorsal stream or the ventral stream, but it usually also involves damage to the primary visual cortex, and as well as damage anywhere along this pathway from the LGN through the dorsal or the ventral streams. Versus a cortical visual impairment, which can involve the majority of the occipital lobe. So what kinds of damage can happen? So if we have damage to the occipital lobe back here, you can actually damage your color perception. You can damage your overall visual acuity. And if you damage the occipital lobe back here, and also the posterior or the back ends of the temporal and the parietal lobes, you can actually have loss of visual field. So the dorsal stream would be lost to the lower visual field, and the ventral stream would be lost to the upper visual field. And then, of course, if it happens on the right side, you can lose left visual field, and on the left side, you can lose right visual field. Now, if we have involvement of the temporal stream, so yes, you can lose some of your conscious or your naming ability to identify things. You may not be able to identify letters or numbers or people or shapes or individual items. Damage to the dorsal stream or the parietal lobe. This can really interfere with your coordination, your overall vision / motor functions. So suddenly walking around, actually navigating a step, this can become problematic. You may not be able to gauge the distance right. You may not be able to relate these functions. So you may not be able to precisely grasp an object. You may want to go beyond it and then pull it back towards you, for example. And also conversely, and also damage to the temporal lobe. If we interfere with the middle temporal lobe, that can seriously interfere with your perception of movement and motion. If this happens, then suddenly you can, like if you're looking at a rabbit in the backyard, suddenly that rabbit just disappears, and suddenly it's at another place, and then it disappears again, and it's in the shrubs. So this disjointed notion of movement This the sum total of these issues with children is that suddenly we're going to have to teach them brand new strategies. The younger the child, the less life experience they have in piecing back together their visual functions. So, if an infant experiences brain damage to any of these systems, you're going to have to start from the ground up. You're going to have to teach them whole concepts of what of what their visual world, what they're lacking in the visual world, and as well as teaching them strategies for how to cope with this. Um, what is also very important to remember is that a lot of these issues do not happen in isolation. So, damage to the temporal lobe is not only isolated to the temporal lobe, it's almost always that the parietal and sometimes even the occipital lobes are involved. And it's not just visual functions. The child can also have damage to other motor functions, causing cerebral palsy. So, gross involvement of the motor systems, paralysis of the limbs, and things of that nature.